Welcome to the Refrigeration Mentor podcast. Hope you're doing well. We're going to be doing a live demo today with my good friend Kevin. He's been on the show many, many times, diving into controllers. He's a CO2 expert. And as always, love that you're sharing, comment on this stuff. Just if you're getting some value from it, please share it with someone. That's it. Or just even like it, write a comment. It's really, really important for others people to see it because I'm finding experts from all around the world and Kevin here. We're going to be diving into some RDM controllers today. Super excited about this. Kevin, how you doing, brother?
Hi, Trevor. Yeah, good to be back. Thank you very much for having me. It's a pleasure to be back. Hopefully, you guys will get something out of this. As you're probably well aware, RDM is something I talk about a lot. I'm not getting paid by RDM. I'd just like to be just like to say at the start, though, I would like to thank Charlie at RDM for hooking me up with a brand new Mercury 3 controller to do the talk on today, because I suddenly realised that all I had was some quite old ones in the garage, and I reached out and they put me up with a new one. So thank you very much for that.
Amazing. Well, then this is what we do, right? We bring value to as many people as we can, and we're going to be bringing value to anyone who's going to watch this or listen to this. So we had a message from one of my good friends, Daniel from New Zealand. He messaged you talking about, man, maybe doing some detailed commissioning process. Daniel was in multiple courses of mine, like CO2 courses. He came into the design course. Such a smart dude. And when I seen his name, you said, "Oh, Daniel from LinkedIn message," and I'm like, "Yeah, let's do a podcast on that. Help him out and help the people down in New Zealand because I know down in New Zealand there's a lot of RDM. Here in Canada there's really nothing, not very much. In the US there's a little bit, but I know this will help people around the world."
I hope so. Yes, and as we said, a lot of the things that we'll do here, even though they are geared for RDM in this case, will apply across the board with different controllers. And yeah, the setup on the front end will be different, but the steps you take to do that case or do that cold store are pretty much the same for all different systems. So, should we get started?
Yeah, let's do this.
Yeah, cool. Okay, so I'm going to assume when we start this, because we're going to talk about this for a long time otherwise, that you've turned up for your cases or your cold store and it's already on vacuum. Somebody has pressure tested it. You've got the vac pump on there, because there's no point in starting anything and then putting the vac pump on, right? You can't do anything while that's vacuuming. So let's get that going. Next thing I'm doing when I walk into any case or cold store is I'm having a look where the probes are. So especially if it's a cold store, standard in the UK is that the electrician, whoever's installing this cold store, let's say, will put the probes in for you. So they'll put an air on and an air off, a return air and a supply air. They'll put the defrost probe and your coil inlet and coil outlet probes in the end of the coil usually. Now, if you've got a really good electrician, they might fit the probes for you. But I'm not a very trusting guy with probes. I'm going to go and have a look and I'm going to see where they are. And I'm going to make sure they're secure, fixed on the pipes. I'm going to make sure that they're the right type. If it's going on a pipe, I don't want it to be an air probe because it's not going to sit very well on the pipe. And I'm going to make sure they're where I want them. I'm going to cable tie them really securely. I'm going to wrap them with some foil tape. I'm going to wrap them with some lagging tape because I want them to read the pipe. If I'm really lucky and it's a big job and there's 2 or more guys on site doing it, then when I power up the controller, I'm going to get my partner to hold one of the probes for me so I can check if it is the probe that it says it is. In reality, is that going to happen on every job? Probably not. If it's a big job, you will. If it's a small job, you won't. If it's cabinets that you're doing, am I going to take every case apart and check where every probe is? Probably not, because I would love to. But in reality, if I've got 20 cases to commission, that's 100 probes to check potentially, and I'm not going to have time. What I'm going to do is, if I don't know that brand of case, I'm going to take one to bits and I'm going to check where the probes are. And if I see that, let's say, the coil inlet probe is not where I like it, I know I'm going to have to do the other ones. If everything looks okay, I'm going to go for it. And I'm going to switch them on and I'm going to see what happens, because we don't live in an ideal world where we can dismantle every cabinet. You will know, if you've done a bit of commissioning, if you've got a brand of cabinet in particular where they always do something wrong. Let's say wrong, let's say to your liking in terms of the probes, and you're going to go check that out. The other thing I'm going to check when I'm looking in cabinets especially is the fan plates. when your case fitters come along and bolted all cabinets together, they're going to remove the fan plate. And what's going to happen is the fan wire is going to be stuck in the back of the blade. And when you switch that on, you're going to get, and you're going to think, oh, no, it's chewing through the wire. So I'm going to do, it's true, right?
Yeah, so, I know. There's so many times.
And the other thing I'm going to do, regardless, is I'm going to check my valves, because I have yet to find a cabinet builder who tightens the caps on the valves after they've installed them. And especially if you're doing a CO2 cabinet, those caps are going to leak. We've said it before on here many times. CO2 valves leak out of the stems. No matter what you do, no matter how good a valve they are, they will leak out of the stems. So I'm going to tighten all the caps. I'm going to check the access point. Caps are tight and fitted, because otherwise, when I'm vacuuming it, it's going to be pulling the Schrader core in, and I'm going to be sucking air in through the Schrader. So I've done all of that, and I've come to my controller, which is an RDM. What I'm going to do, especially if it's a cold store, is I'm only going to power the control breaker on first. I'm not going to turn on the heaters. I'm not going to turn on the fans or anything else. I'm just going to concentrate on getting that controller online. So if it's RDM, there's several different ways we might be going online. RDM likes IP as its main networking. It will also do RS485. And you can connect, if it's on IP, you can go different ways. You can go to a hub that RDM will supply you, and you can have multiple fixtures in there, in which case some of the addressing is done for you. You can go straight IP to a regular network hub, or as I say, you can go on RS485. RS485 is losing popularity in the UK. Everyone wants IP for many reasons. With 485, it's been around forever. Everyone knows it. 2 wires, cheap cable, and you've got massive distances you can do, but it's vulnerable. If you short those 2 connections together, you get a break in the cable somewhere near the panel, you are losing the lot. IP is more resilient to that. You can still have 1 cable from the where the panel is to all your fixtures, but you've got to be extremely unlucky. And if you lose everything, it's that cable, right? So IP is that if let's say it's a deli case, everyone loves a deli case, and you've got mice under the deli cases, because where isn't that the case, right? And a mouse chews through the cable. If it's IP, you're going to lose that 1 fixture probably. If it's 485, you may lose half the store. So RDM over the years have had various ways of connecting networks. The original controllers came with what they called an RS232 output. Again, 232, 485, IP, you could go real deep into what they all mean, but it's, for our purposes, it's different languages. English, Spanish, French, or whatever you want to call it. And just because the cable looks the same, it doesn't mean it's talking the same language. So on an RDM controller like this one, the socket on the side is a category 5 socket, regardless of what type of network it is. This actual one puts out 232. So don't be fooled by the type of cable it is. Anything you've got on RDM that's in this format will have a category 5 type cable on it. So if it's direct IP, it will tell you on top of the controller, the model number will say IP on it. If it's 232, it will say 232 on it. And they keep it simple. They do help you. I'll show on the screen in a minute. If it's 232 and you want to put it on an old 485 network, they do a module to convert the standard. It's a translator. It might be green. It might look like this. This is about 100 years old out of my garage, as many of my things are. If it's a 232 controller, you can still use it on IP with a slightly different module that converts it to IP. And that was the way we used to do it, everything on RDM, before they put direct IP into the controllers. So you have options, but just because it's the right type of cable doesn't mean it's IP. You've got to check what type of network it is, and you've got to know what you're plugging it into, otherwise it ain't going to work. So on my bench at the minute, I'll just share screen, Trevor, so we can see on my desktop. Hopefully that will play nicely and share the screen. Yes.
So whoever's listening to this, definitely go to the YouTube channel and check out the video from here for sure. Diving in, because this is live controller commissioning. Love it.
So hopefully we have my RDM screen on there now, Trevor. Yeah. Cool. Okay. So just to illustrate what I was talking about before, that is an IP controller. Because it's an IP controller because it says IP on it. they make it pretty simple in that regard. And obviously they very handily give you a wiring diagram on the back where everything needs to go. A couple of things to point out on here where it says NC. On the mains, NC means not connected, not normally closed. Don't put anything in there. On the relays, it's exactly as you would expect. Normally closed, normally open and common. Okay, they're all volt-free relays down there, so you've got to put a supply onto them. If I show you an old one, if I can find, yeah. So this is my old been in the garage 10 years controller, RS232. Okay, so even though the socket looks the same, it's RS232. On the newer ones, it will say it in the model number as well. Okay, so let's get my display back up. Right, so this is a data manager screen for those who've seen them in the past. It's this is their RDM's front end. Fantastic piece of kit. Makes everything nice and simple to use. I've had a lot of devices logged on here in the past. My new RDM controller, which I've just powered up, is that one. So all I've done for that is I've gone into the controller network menu, and there's an option called ID. And it's a 3-digit number, and I've just picked any 3-digit number to put in there. If I had 50 cases to do in a store, I would do it very logically. I would start at number 1 if it wasn't in use, and I'd get to number 50, as you do. So RDM is brilliant for logging on new controllers. With many types of panel, you need to tell it what controller you're logging on and what address. Yeah. With RDM, it figures it out for itself. The moment it sees it on the network, it will ask the controller for a type file so it knows what to do. It will then load the type file and your controller will appear on there. On the front of the controller, the green light for network will go solid and it will say I'm logged on. So that's happened on that device. What I'm going to do, which should be good for a laugh, I've got the other controller I showed you a minute ago, this one, been in my garage for a solid 10 years. I'm going to try and power that up and get that to log on as we speak. It may work. If it doesn't, we'll know that you should try these things in advance. But I think it'd be a really good exercise to see if a 10-year-old controller will talk to the network while we're doing this.
Love it.
So because I'm going IP, I have my module and I have my 3 dials to set an address right there. Right, so it's hundreds, tens, and units. I'm just going to set number 1 to 3, and we'll see if that logs us on. I'll plug it in. If it doesn't go bang, it'll be a sweet miracle when I connect the power up, and we'll go for it. And while we're doing the other controller, if that logs on, we'll be able to see it. So while that one's sorting itself out, let's have a look at the one we've just logged on. So I've switched my controller on to start with, and it's come set up by default as a case controller, as we can see. Now there's a menu on the RDM controller called type. You've got types 1 to 6 on most of their controllers, and that gives you presets, right? So that will give you whether you are on a case, let's say, or a cold store. It will give you certain default options like, do I want fans on in defrost? Do I want a door switch? Just things like that. If you select the other options, which are for what we call a mobile controller, it's a self-contained cabinet, it will give you parameters for compressors. If you look down the parameter list for this controller, you'll see there's nothing in there for compressors because it thinks this is a piped case. And this is an electronic valve controller anyway. It wouldn't expect normally a mobile case to be an electronic valve. Okay, so when I first plug in, I'm looking at it, and first thing I see there is obviously it's over temperature. I've had it plugged in for a little while, but bear in mind this is degrees C on my screen. The temperatures look real high. Yeah, now I know I've got a t-shirt on, but it is not 43 degrees in my office today. So the minute
I UK, like, come on.
Yeah,
now.
well, I mean, it's never 43 degrees in the UK. It's 43 Fahrenheit, maybe. Yeah. So I'm immediately thinking when I see that, am I on the right range of probe? Because RDM supports multitude of different probe types. Read the manual is what I would advise on that, and just check your probe types. There is a menu called Unit on the RDM controllers, which lets you change that probe type. You can do it through the buttons. If you're connected directly to the controller, you can do it through the network. Everyone is going to do it through the buttons, realistically. So you're going to go into the unit menu and you're going to compare the number that's set in there to what type of probes you've got fitted. So for me, I'm going to do it right now as we're speaking. I know that I've got PC1000 fitted, and I know that they're type 0 on an RDM controller. So I'm going to set that. And when that refreshes itself in a minute, we'll see how our other controller's doing as well while we're waiting for that. Oh, look at that. It's actually logged itself on. There we go. So, so number 300 there is the controller that I just connected. So that's, I think, a pretty good demonstration with RDM of how robust it is with old controllers. That my data manager is about 18 months old. The controller I've just connected is well over 10 years old. And all I've done is put an address in it, connected it on, and it's appeared. So that is the beauty of using these. There's no type files. There's no, like you get with some manufacturers where you're going, oh my God, that's a really old controller or a really new controller. Where's my type file for it? It'll go straight on. So that's a miracle. I'm quite pleased that's come up. That's right up.
What refrigerant's in that one?
What's refrigerant? You say yes. I think that it nearly predates CO2, that controller. Right. In the meantime, back on the case we were on. Now I've changed the probe type. That's a little more realistic. It is quite warm in the office. I've shut the window because I don't want to hear the neighbours while we're doing this. But now we've got realistic numbers, right?
Yeah.
So I'm happy with that. They're all saying virtually the same, which also is good news to me, because if I've got 3 saying 25 and 1 saying 35, I'm saying they're all in a room together. Why is one much higher than the other? I also noticed from that, I've got a suction line probe fault, right? And the controller's flashing PRB4 on the front, telling me it's a probe 4 fault. If I go into the alarm log for this controller, it's also telling me I've got a probe fault. Now, because it's 2 foot away from me, I can see I haven't put the wire in. If you're out in the field and you're doing this, you're then going to be checking where that probe's connected to. Is the wiring properly? Has somebody stood on it and ripped the cable out? Standard, especially if it's a cabinet. When the pipe guys are going and putting the headers in, they're always ripping the probes out, especially if they're Danfoss PT1000, which fall out if you look the wrong way at them. Brilliant probe, falls out very easily. So the next thing I'm doing is I'm going chasing that fault, and I'm going to put that wire back in. So I've got all my probes reading at that point. I'm happy they're all saying the right thing. I'm not going to do it now. I'll probably get electrocuted from my dodgy setup. But let's just say I put the probe back in. While I've been doing this, because this is a pulse valve controller, an AKV, I'm sure we all know what a pulse valve is. I've been listening, because when these power up, I'll get a click, and I'll get a regular click out of a pulse valve. And if I've not heard that click, I'm thinking, why have I not heard that click? Have I got a fault somewhere? And if that's the case, I'm going to check the outputs. In this case, because I've got a probe 4 fault, it's not going to drive the valve. Normally, that would just say, I've got low superheat, I'll go to my minimum valve opening, and I'd get a 10% duty cycle on the valve. And I'd, every 6 seconds, I'd get a little click, and I'd know the valve's talking. Because it's on vac, it's going to be quite a tinny little sound, and I'm happy then that my valve's working. One thing to note with RDM, if it's a mechanical valve with a solenoid, it is wired fail-safe. So on the back of your controller, it's wired to normally closed, as are the fans, right? So check your relay 1, your relay 2, wired normally closed. This is basically so if the controller blows up at some point, or somebody spikes it or whatever, you've got a little bit of a chance of keeping your food cold. And you're hoping then that somebody's noticed it's gone offline and they're going to do something about it. But that is how they guarantee that you've got a bit of cooling. So normally closed for fans and valve. On an electronic valve, the third terminal isn't connected because it's not a relay, it's a transistor. So you're normally open for electronic valve. Okay. So I'm listening to that. That's pulsing away. I'm happy. I'm then going to switch my fans on. And with a fair wind, the fans are going to start. And I'm going to be like, yes, I've got a chance of running this today, which is what we all want to do. I'm also going to be looking at my transducer, if I've got a transducer fitted. Now, what I'm going to bear in mind is if I'm on vacuum and it's not a -1 to something pressure, let's say 1,000 psi, 100 bar, whatever. If I'm in the vacuum and it's not rated to -1, I may be showing a fault. If it's a -1 to 65 bar transducer, I should be showing a reading on my transducer at this point. RDM likes 4 to 20 milliamp transducers. There's a good reason why we use 4 to 20 milliamps, and that's to detect open line. If it goes to 0 milliamps because the line's open to the transducer, you'll get a fault. So I'm going to be checking to see if there's a reading on that. I'm not going to worry too much if it tells me when I come to set it up that there's a fault with the evaporating temperature, because RDM knows that you ain't going to operate this below the triple point. And I wouldn't be worried about the reliability of that reading until I've got pressure in it. What I'm just checking is that there is something there. Now, I would have loved to have demonstrated that, but unfortunately, all my transducers I've got at home are 5 volts. So you're going to have to trust me on that is what you're going to be checking on your transducer. You're going to need to put some parameters in your transducer to get it to read anyway, which we'll come to in a minute. But bear in mind, on a 4 to 20 milliamp, if it's open line, you'll get a fault because it needs 4 milliamps to say 0. Yeah. Okay. So what you sometimes find, if it's, let's say you haven't started a vacuum for whatever reason, or somebody hasn't fitted your transducer and you've got a 0 bar bottom of the range, what you'll sometimes find is the reading will go in and out. 0 on a 0 to 60 bar transducer is right on the edge of detecting a fault. So if you're not sure, if it looks a bit funny, put some standing pressure in it. When you've finished vacuuming it out, just open the suction, let the pressure come up and see what your reading looks like. Compare your reading you get then to what you're getting on the rack or what you're getting on your gauge, depending on where you got connected, and go from there. Yeah, it's one of those where you can easily start chasing a faulty transducer only to find that you just need to put some pressure in it and it'll be fine.
Yeah.
Okay. So I am then going to have a look. I've switched my fans on. I know my probes are reading okay. I'm going to start having a look at some parameters. Yeah. And what you find with RDM is that majority of the time, the default parameters will start the fixture up. Yeah. But they are almost certainly not going to be what you want. Now, if you've selected a type file out of it, your types 1 to 6, that's LT, it'll default to -20. If you've, as your set point, if you've selected HT, then it'll default to 0. Yeah, on a 50% weighting as they are there. So that's taking its control value to be 50% of the air on, 50% of the air off. Now, your case manufacturer is going to tell you what you want on that. RDM percentages are, your number is the percentage of the air on, right? So if you set that to 100%, that is reading 100% of the air on, i.e. exactly what the air on probe says. If you set it to 0, it's reading 100% air off. Now, that is the reverse of things like Danfoss, where if you set it to 100%, it's reading air off. So just make sure you set that the right way around. You'll soon see, because when you're actually running and you've got a differential on your probes, if you set it the wrong way around, it's going to read exactly the same as the probe you don't want, but it will be relative to air on or air off, that one. Go by what your case, if it's case, go by what your case manufacturer is saying. If it's a really good case manufacturer, they may have set your case up for you. Don't always count on them having done that, because some of them won't have. If it's a cold store, you're going to be on your own. Cold stores usually 100% air on, because you want to read the warm part, right? You want to read the air coming back out of the room. The only time I would deviate from that on a cold store is if you've got, let's say, a dual discharge cooler in a teeny room and you've got a really bad situation with air bouncing around the room. It does happen. Certain customers have little tiny prep rooms, for example, and if you just did it by air on, it would not reflect what the room's doing, because the air off influences it quite a lot more in a small room. So you might need to fiddle with that. The other thing you can do, let's say you're controlling on air off because it's a refrigerated cabinet. A lot of refrigerated cabinets control on air off because air on gets affected by drafts. Sometimes if the customer sees the display saying -3, because that's the air off temperature, the customer's panicking if it's produce that it's too cold, right? So RDM lets you show a different value on the screen of the controller to what it's controlling against. So that one will be how the thermostat operates, and that will be what shows on the screen. Right.
Okay. Let's just, can we just go back through that one more time? Because this is different than a lot of controls that people would see. So When you say
So,
control weight, that means air on. Is that correct?
So it depends what you set it to. So yeah, so control weighting is where it's getting its control temperature from, right? So where it's 50-50 at the minute, it's taking the air on and the air off, and it's using 50% of each, if you like. So it will be the average of the two, effectively. It'll be right in the middle. If you set it 60-40, it will take 60% of the air on and 40% of the air off, and it'll work out the value. You set it 100%, in RDM's case, it will read all air on, right? If you set it to 0, it will read all air off.
And so air on is
air on is return air.
Return air. Just wanted to clarify that, right? So we get the return air on. That's the air going onto the coil. Air off is the discharge or the supply getting blown out. For an example.
That's it. Yeah. So if I try not to kill myself and hold the air on probe, if I've got the right one for a minute, we'll wait for it to refresh. We can have a look at that. If I set the parameters a minute to one way or the other, we'll see what.
Thanks for explaining this, because when I talk to lots of people from around the world, the terminology is so different. It's not super different, but
of course, you know it. Well, it's and terminology is key in our industry, isn't it? Everyone calls things different things. So, right, let's wait for that value to update properly, which it will do in a moment. As it took my parameter change, let's have a look. Right, control weight 100%. So eventually, when that gets a grip of itself and updates, the control value is going to go to the air on, because I've raised the temperature of the air on now. It's just the speed it updates. It will eventually end up at the air on, and you'll get those two values reading differently.
31 Celsius now and 25.
So when it eventually updates itself, there we go. Right, it's got a grip of itself now. So you see, it's reading all of the air on value. Whereas before it was reading an average of the two, and that's because I've set it to 100%. The reason the display weight is still on 50. Sorry, the result of the display weight still being on 50 is that's still showing you the average of the two. Yeah. So
that's a good way for, like you said, if the customer's all worried about the produce because it's saying -3, but actually that's the coil temperature. That's a big difference.
Yeah, exactly. And it's especially the case if you've got, let's say, like a fresh meat cabinet and you want that air off. You want to control on that air off, but you want that -3, -4 Celsius. If they see that on the screen, they're like, why is my case so cold? Because they only want to see like 0 Celsius on that screen, right? So, and this is how we check the probes as well. All I would do in a cold store, I would have somebody holding that probe and I would watch what the value did. And I would then check, because I know that's the air on probe now, because I've seen the number go up. And it's worth saying, and good point you make about the probe settings and what people call them. So you can, through the data manager, change the names of all of these. You can go into aliases in here and change the names of any parameter you like. So let's have a quick look while we're at it. So I'm on controller 600, and I can just change the name in here. I can call that supplier. And then when I go back into the controller, that now says supplier. And we can do that with any item. We can do that with any input, any output, any parameter, and any alarm. So if we want to call things, classic example is cold stores. So RDM calls all its alarms case. Even if I change that to a cold room, it will still say case over temperature when it alarms. But I can do an alias change through this panel, and I can change that to say cold store high temperature. And it's all about what your customers want to see. You know what the customer's going to see. If they're sort of really on it, they're going to go, why does it say case over temperature? It's a cold store, right? And that's potentially confusing. I can also set the name of this fixture in the panel, which I would obviously do. I would set it to what it is. If it's a meat case, I set it to meat case. If it's a produce cold room, I'll set it to be a produce cold room. So,
and that's very important on the startup, so that technicians know. You just close the save password. Very important. So when you go into that store and it's meat case, it said, you're going down to the meat. You know what I mean? Not the produce.
Yeah, and it's worth bearing in mind if you change a controller and it comes back up case controller HT or LT or whatever. All you've got to do is go aliases, names, find your device right there, and we can change it to be whatever we like. Yeah, and it's as easy as that. And then we'll know what that fixture is. It'll eventually update. That's my fault. Okay, there you go. Look, it's updated now. I'm going a little fast for it. Okay, so in our parameters that we're going to do, other than that, alarm weight. So you might not want it to alarm on air on or air off. Depends what setup you've got. If it's a cabinet, alarming on the supply air probe is probably right. That's 0%. If it's a cold store, you're going to be more concerned about the supply air temperature, the return air temperature, sorry. So you can set that to 100%, and that will then alarm when the cold store gets warm rather than the supply air into the cold store gets warm. You then got your EEV settings, because it's an EEV controller. You can set your superheat reference in there. 6 is a good starting place, as we know. If you need to turn it colder, you need to turn it warmer, you can do it from there. Response on and response off is how fast the controller responds to the superheat changing. So when I first do a case or a cold store, I'm not changing those. I'm going to see how it runs. The RDM has spent many years developing this controller. I'm going to give their settings a chance before I start changing superheat settings, unless I've got a very good reason to do it. And the same with...
I think that goes with all manufactured controllers. They do all a good job nowadays, you know what I mean? 100%. Like all the algorithm. Start with what they say, and before you start going in and adjusting P and I's and D's and stuff, it's just...
Yeah, absolutely. You give their settings a chance. RDM doesn't get into the PID bit on this. It does just response on and response off. And
it's good because that does change it internally, but it doesn't force us to look at the I think Danfoss is going that way as well with theirs.
And what we know, we all know very well, is that everyone loves to see P, I, and D there, but actually quite comparatively few people know what P, I, and D actually do. And what happens is people fiddle with P, I, and D and end up with things not working how they wanted them to. So what I will say, Carell, if you want to mess with P, I, and D on stuff, Carell do a very good guide in their documentation on how to tune P, I, and D on fridge controllers. So do check that out. It's on their website. It's really useful, actually, for if you want to get into it. It will say, if you double P, it will do this. If you half I, it will do this. We digress onto Carell. I should not do that. Other parameters for the valve right here. So if I see a superheat problem, what percentage am I going to go to? Now, the reason they keep 10% in there is for if you're not using a transducer. If you're using a probe, it wants to keep trickling some refrigerant through it, so you've got a chance of rectifying itself. If you're using a transducer and it sees a superheat fault, you can set that to 0, not a problem. And it'll then wait for its problem time, and then it'll try and start the valve up again. And that's useful if you've got a brief issue with the rack that you've solved, and then the case will get away by itself. If you've got an iced up coil, you don't necessarily want a problem opening of 10% because you're going to keep feeding that coil 10% refrigerant all the time. You might want it to say, no, I've got low superheat, I'm going to stop. Right? So depends on your setup.
So when does the minimum open? So on startup, right when the digital input closes, you go to 10%?
So yeah, minimum input minimum opening is in normal operation if your superheat is below target but not critically bad. That hasn't hit your low superheat number, which is your superheat problem number there. That's the minimum it'll go open to. Normally we would have superheat problems set, let's say 2 degrees C, something like that. If it gets below that limit, it's going to go into problem. Yeah, and depending on how you set that, it's either going to shut the valve or it's going to keep the valve at a low level. The problem when you're only controlling on probes, if you're not using a transducer to get your inlet temperature, your evaporating temperature, if you shut the valve completely, you may, let's say the coil's absolutely clear and you just had a rack issue, when you start it up, it may struggle to get away because you've not got any temperature sensed at the inlet. So you can set it to keep a little bit of refrigerant coming through on the basis that 10% shouldn't flood the coil. But if it's a fully iced up coil, it may well flood the coil at 10%. So if you've got a transducer, there's nothing to stop you setting the problem opening to 0. Okay, so I won't go through every setting. Read the manual. There are thousands of settings across RDMs.
I think it's important too, read any manual, but for an example, start opening percentage. That's going to be different if you're on a chiller versus a long run cold storage. Because if you have that at 75% open start opening and you're only 2 feet away from the compressor, you're going to be in some trouble.
Yeah, 100%. And it's another one where, let's say you've got a 12-foot frozen case that defrosts with electric heaters. Especially if it's got low speed fans when it's on defrost, if you set start opening to 10% and you're controlling on probes, the chances of you having any liquid arriving at that probe before the valve stalls very slim. So you need a chunky start opening to get liquid to it. If you're operating a case that's chilled and is off cycle defrost, you can set that to like 10%, 20%, and it will get away. If you've got a transducer, it's even less of a concern. You can set that as low as you like and it will still get away because it can see the superheat immediately. All the start opening is there for is to let you stabilize the superheat. Yeah, it comes from a time when we didn't use transducers, really, in all honesty. It's just about settling the superheat down. But one thing I will say, just as I say about reading the manual, I know nobody enjoys reading every manual going. RDM constantly evolve the software in these controllers and new parameters appear all the time. Right, so even on this controller, see how many parameters there are here. This is why I'm not going to talk about every parameter in this, because I wouldn't use every parameter when I'm commissioning an average fixture. You know, they are covering every base with these parameters. But a classic example of involving the parameters, I plugged this controller in earlier to set it up, and I couldn't change parameters on it. The reason being, if I'd read the manual, RDM have changed the security structure now, so you have to change a setting to let the data manager alter settings for you. And if I'd have actually read the manual before I plugged it in, I would have known they'd done that. So, read the manual.
So let's talk about maybe the 6 or 7, because there is a lot that you're showing there. But what are like 6 or 7? Like MOP is a big one for sure.
Let's look at MOP.
I didn't see it on there, but I'm sure
MOP
it is.
right there. Yeah. So this at the moment isn't configured for CO2. MOP, we've talked about it a few times. MOP is really useful for controlling load on the rack or for stopping load, depending on how the controller's set up. Yep. So with RDM setup, you set an MOP pressure into there. If the controller hits that pressure, senses it's hit that pressure after the MOP delay, it will shut the valve by whatever percentage you've set div value to, which is a parameter way up the top. So they are div value. So if I set MOP to, let's say it's CO2, let's say I set the MOP to 40 bar, 600 psi, whatever it is, it will, if it hits that and the time elapses, whatever percentage the valve's at, it's going to half it. If the valve's at 50%, it's going to set it to 25%. And it's going to do that until the controller senses that the pressure has dropped by the MOP differential. And then it's not going to put the valve straight back to where it was. It's going to let the valve start controlling again. And it's going to keep doing that until it sorts its pressure out. So it's load control. RDM has many other ways as well of doing shutdown, but that's your primary load control, if you like, through your controller. So that's a really important one to use. What else? We've got loads of different settings for fans, for fan management, right? Yeah. So you can ask the fans to run all the time. You can ask the fans to stop when it stops cooling. You can ask the fans to stop on defrost. This is one to read in the manual. So you can set fans that, for example, fans temp mode in there to temp. And then if you get to that temperature, it will switch the fans off. And this is stock protection to a degree. It's really for if the controllers, not the controllers, but the system's failed, right? And you've got a freezer case. If it's not doing any cooling and it's got to -10, there's no point in the fan still being on, is there? Because all you're doing is putting heat in from the fans. So you can tell it to switch the fans off when it gets to that temperature. You can, with fan control, you can tell the fans to run all the time. You can tell them to run when cooling's on and not run when cooling's off. And if it's not running with cooling off, You can tell it every few minutes, I want to pulse the fans just to blow a bit of air around and check what temperature the room is, right? Because if you switch the fans off, you can't sense the temperature accurately. So it will bring the fans on every so often to do that. You can tell it what Probe 5 does. In this case, it's defrost. You can set it to be monitoring as well. You can tell it where the lights are. This is where you tell it, how am I sensing my evaporating temperature? Yeah. So if we have a little look at what's in that, because that's an important one. Evap select, which is right there. So local is saying, right, I'm using probe 3, my evaporator probe, and that's how I'm going to sense my evaporating temperature. I can tell it to read a probe from the network, from a hub that I'm connected to, or from a network device using REM 1, REM 2, and REM 3. I can plug a transducer into it. Usually, by default, we're using trans MA if we do that. Transducer, milliamps, right? And then it's going to be looking for you to set the settings down at the bottom to tell it the range for the transducer, which we'll come to in a moment. Yeah, so if I do it, it's going to declare a transducer fault now because I've got transducer wired into it. Switch resistors, that's the useful one. So you can tell the controller by putting a resistor across some of the probes to put itself into fans only, put itself into lights only. You can tell it to do a defrost. You can tell it to do lots of things with the resistor across the controller. Again, explained in the manual, but if you want that function, you need to turn it on. And then you will have the option, depending on where you put that resistor, to do different functions. It came from a time before we had digital inputs on the controller. You can do the same things with the 2 digital inputs that the controller now has. Gives you more options to do more things. So, for example, on this one, you can tell it, okay, digital input 2 is a plant fault, and it's a normally open signal, or it's a normally closed signal. Case switch is going to switch the case on and off. If it sees that input, it's just going to go to off. Use that one with caution, obviously, because if the case goes off, that tends to be bad for cooling. Temp switch, you can switch it between temperature ranges. You can set 2 different temperatures, and that will switch between 2. Or you can tell it, if I see that input, I'm going to go into defrost. Yeah, that's quite useful for things like gas defrost. If you're initiating a gas defrost from a central controller, not something we tend to do in the UK now because gas defrost has died a death, but something that definitely still happens, I know, over there very frequently, doesn't it? So that's a good option if you want to send it a digital signal to do it. What else we got? Temperature alarms tend to be quite important. Temperature alarms, we like a temperature alarm. Set them sensibly. You know, customers, if they see a temperature alarm all the time, are going to ignore it because that's what customers do. They need to only see that alarm when it's serious, right? I don't know who uses under temperature alarm on freezers these days. Under temperature alarm on chillers for when your valve's stuck, definitely. And over temperature alarm for everything. Set it realistically. Customers are going to have a spec. If you're doing a customer that hasn't got a spec, you're an engineer. You know how high that fixture is going to realistically go during normal operation. And it's going to depend what it is. If it's let's take a popular one. If it's the cafe cold store in a Costco, let's say, that door during trading is going to be open 11.5 hours out of 12, right? So if it's a freezer and you set that for -15, it's going to spend the whole day in alarm. Yeah, so we all know we need to educate customers what doors do, and we all know what realistically happens. So set it with some view to what the room's doing. If it's a deep freeze cold store that's going in once or twice a day, set it tight because you want to know when that's going to break down. And if it's a massive room, it's going to have a huge amount of inertia on that temperature. So if it's got to -15, there's a problem. So set it tighter. Smaller room's going to lose temperature faster. If it's a case, the manufacturer's going to have a spec for it. Set it in line with the spec. Change that spec at your peril because most customers will have you strung up for changing the spec and they lose product. So stick to customer spec where it exists.
Yep.
Logging probe is something that a few manufacturers do. RDM's had it for years. You can fit what they charmingly call a slugged probe. Everyone loves a slug in their cabinet, which is a probe stuck in a big block of polystyrene. that goes under a shelf that responds much more slowly, responds as it was originally designed, like a chicken would if it was on a shelf. Because just because the air temp's gone to 10 degrees, if it's a chicken and it was at 2 degrees 5 minutes before, it ain't going to be 10 degrees in 5 minutes. So that gives you a much more stabilized response for the shelf temperature. Yeah. So that goes into probe 6, usually, on an RDM controller, and it's got its own temperature ranges. Okay.
Yeah. There's tons of them.
Oh, hundreds. I'm not going to go through all of them. Probe 2 is useful if you've got a controller. Let's say you're putting an RDM controller in something that only had an evaporator probe and an air probe previously, and you just want to retrofit it. If you switch that off, it won't alarm if probe 2 isn't reading. Normally, it will alarm if it doesn't see probe 2. If you turn that off, it will ignore that input. So if you're changing an LE well or a DIC cell or something that's only got one probe, really useful for that. All your defrost settings are very common across all the manufacturers. Worth noting, defrost number, different to some manufacturers, is not how many hours between defrost. It's how many defrosts per day, right? So, like, you get some manufacturers who say, you know, your defrost hours or your defrost interval, 6 hours, let's say, right? Carell's a good example. Carell says defrost interval. If you set it for 6, it'll be 6 hours between defrosts. If you set defrost number for 6, you'll get 6 defrosts a day. Okay? And no defrost time, if usually it's for when you're doing a remote signal. Yeah, so if you're sending it an external signal, if it doesn't see that signal for that many hours, it's going to give you a missed defrost alarm, and it's going to go into an emergency defrost. If it's gas and it's initiated from the pack, you've got an off-cycle defrost you're going to get. If it's electric and it's just getting a remote signal, you will get a defrost at that time, and it's going to give you a missed defrost alarm, so you know it's done it. Yeah, those pretty self-explanatory, pretty much on every controller. Recovery time is how much time the alarm doesn't sound for on temperature after a defrost. Yeah, and you've got all your fan settings and light settings and all that good stuff. Lights and defrost can be set on a timer. In the wrong one, if I went into the right one, it would help. In the front end, you've got a timer option. You can ask the front end to do all your timers for you. Yeah, for lights in GP timer and for defrost in defrost timers. So if you've got 100 fixtures, you want to do them all nice and neatly, set them up on the data manager, and set the controller to get remote defrost. Same with lights. If you want all your lights to come on together, you set a timer. I won't do it today because it's a whole other topic. Set the GP timer up, set your light signal on your cases to remote, and all the lights will go on and off. That's really useful where you've got remote access to a store and they're saying, we want to stay open another hour's trade-in. Can you put the lights on? You don't want to adjust the light timers on 100 fixtures. You just do it once on the panel.
You don't want them on today? Outside the parking lot lights all day?
Yeah. Well, exactly that. You can do exactly. Yeah, exactly. You know it. So, yeah, if you want to do it on the cabinet, if it's one cabinet, lighting times are right there. So, when you're coming to set up your transducer, a bit like we talked about previously, all your transducer parameters are right here. Yeah. So you can set a refrigerant type. Ref weight, it explains in the manual. It's nobody should need to change that normally. You've got, do you offset it from the reading that you're getting for pressure drop? Is it an HFC that's got glide? Do I need to set glide in there? And then you've got your basic transducer span and offset, as we discussed on the last one. Span from the bottom of the transducer to the top. So if it's a -1 to 65, your span is 66. Offset is, do I need to adjust it the bottom end below 0? So if it's a -1 transducer, that will be -1. Yeah. MOP, as we talked about. Custom settings for refrigerants and probe offsets. Yeah. If you've got really long cables, again, we've talked about before, if you've got really skinny cable and really long runs, that cable is going to carry a resistance. And on PT1000 probes, 4 ohms per degree, that's going to affect your reading. And so you're going to measure the resistance of that cable and offset your probes in here so that you don't get crazy readings. Okay. So
more than big, I see it more in industrial stuff now too.
Yeah,
so.
100%. Yeah. So In my real commissioning world, I'm going to put my parameters in there. I'm going to start the fixture up. I've backed it out. I've checked the tour. I'm going to open it up. I'm going to let it run. I'm going to watch what these readings are doing at that point. I'd have fixed my suction probe and I'll be watching the readings. So I know what's going to happen realistically, right? I know the evaporator probe is on the inlet to the coil. I know it's going to get the coldest straight away. I know the air off probe, probably going to be the next one to get cold. And depending on where the defrost probe is, maybe the defrost probe just between the two. Supply air, I'm going to expect to be the last one to get cold, really. If that isn't happening the order I'm expecting it in, I think I'm going to have a problem on one of my probes and I'm going to be going in and chasing what's going on. If I'm really lucky, I can run in, grab hold of a probe and check it on the screen outside. If you go into the first menu on the controller, it shows you inputs and outputs. IO1 is control temp, IO2 is display temp, 3, 4, 5, and 6 are your probes. It tells you in the manual. And I can have a look and make sure the one I've expected has gone up. Yeah, it depends how good your electrician is, whether they put them on the right places or not. So I'm going to check that's working. What I'm going to do is I'm going to let the case get cold enough that it's then going to do a defrost. And I'm going to initiate a defrost and check my heaters. If I've got heaters, you can do it with the bottom left button on the controller. Hold it down and it will go into defrost. This one won't because it's too warm, but you can do it on a live one. I know in reality, everyone's going to push the contactor in to do it, but you do that at your peril. Yeah. And I can tell you right now, the last job I commissioned at my old place, I did exactly that. I'm no different to anyone else. And what had happened was somebody had miswired the evaporator and I had a direct phase to neutral short in the evaporator. And I jumped quite a big way back from the panel when it went bang, because it was a big circuit. So I'm going to tell you, do it the proper way, unless you're brave. And I didn't tell you to do it. But yeah, check your defrost. You know what's going to happen with your probes on your defrost. You know what's going to come up. Make sure it terminates. Make sure it doesn't get red hot. Yeah, you know how that's going to work. And then for me, what I want to do is I want to run it overnight. And then I want to check the graph in the morning. And I want to see my defrost peaks on the graph. And I want to see that it's been running stable. Yeah. Another beautiful thing about the way the RDM does it, you don't have to configure this graph. It will log all the data points, right? But it's just giving me control temp there. I can tell it select trace and I can select my supply air, my air off, whatever. It's going to show me all those different traces. Yeah. And if there's something I don't like, I can shorten the range down a little bit. I can look at it in detail and I can see exactly what's been going on. I'm not signing off on anything I've commissioned unless I've seen it run overnight. Yeah, because what always happens is it works perfectly when you're watching it, and then you leave it alone for 20 minutes, a bit of dirt comes down the pipe, wedges in the valve, and it doesn't do a defrost. And then they shout at you when it's iced up. So that's where I am with those. Like I say, RDM does a lot of the legwork on your setup for you. You know, all I've done with that is told it a name, and I've named one of the probes. It's logging all the data for me. It sets all the probes up. I've plugged, you know, a 10, 12-year-old controller straight into it, and it's come online without me doing anything. So it is a massive labor saver for you guys on site, compared to some of the torturous ways of setting stuff up. I'm not setting points up or anything like that. It's already knows what type of controller it is, and it's done all the points for me.
One of the things, because man, we could talk for 10 hours on this stuff. The trend graphs are, I think, super key for technicians. So you set this up, everything's looking great because I know you just showed it. What are some of the top things on a case controller that you like to watch to make sure it's running good? Like what graphs? Like
so I'm going to
percentages.
Yeah. So I'm going to watch what the superheat's doing. I'm going to want it to be stable. It's like we talked about in the last video. If I see the superheat's hunting up and down, I'm going to look. What's causing that? Is it the suction temperature bouncing up and down? Is it the evaporator temperature bouncing up and down? If it's the suction, am I doing something wrong with my case setup? Have I got the superheat setting too small and we're into unstable? Have I got the response time too fast and the valve's hunting? Have I got a poor airflow over the coil and a little tiny change in the valve is killing the suction temperature? If it's the evaporating temperature that's moving, then is it the rack's not stable? Is my transducer all right? What's causing that reading to move up and down? I'm also looking at the air on temperature. So I know the air on temperature is going to be warmer than the air off, obviously. If it's way high, if I've got let's say -2 Celsius air off and 12 degrees air on, why is it so high? Is something blowing into my fixture? If it's a warehouse type retailer and it's got a big old train unit blowing around, it's going to be blowing in the case. I can pretty much guarantee that because they always are. If you've got cold aisle heating in a supermarket, that can blow into cabinets. We've got a lot more doors coming in on fixtures now. It's a lot rarer to see that, but I'm checking that. When it's on defrost, I'm checking my defrost termination probes and met the temperature, because if it's terminated on time, I'm asking myself, why is it terminated on time? Why has it not made the temperature? Have I put too high a temperature in? Is the valve not shut? And I can check my evaporator temperature for that. My probe, regardless of whether I'm using a transducer or not, that probe's still on the inlet. If that doesn't come up during defrost, then I'm bleeding liquid in through my valve and it's going to hurt my defrost. So I'm checking all of that when I look at the graph. I'm checking my defrost tablet at the right time where I've scheduled them. And if all of those things are looking good, then I'm saying, yeah, okay, I'll let that cabinet pass. If it's a cold store, especially if it's a freezer, I'm going to pull it down in stages. So I might drop the temperature another couple of degrees the next day, depending on what the pull down pattern is, so I don't crack the floor if it's a new floor.
But oh man, I don't want to tell you about some of the stories of cracking floors.
Oh, always the threshold, man. Always the threshold is the thin bit of it.
That's how you learn, right? No.
Yeah, of course it is. Of course it is. Well,
do not pull it down as fast as you can.
It's when the job's gone wrong and you start pulling it down 2 days before handover, isn't it? It's always the ones that
we're gonna open it up. We're gonna roll stuff on the floor.
You know it. You know
the floor is still drying.
You know it. You know it. Yes. This is it. So that's it's very true. The forklift drives over it and a big hole appears. No, it's check it afterwards. Don't assume just because it worked when you commissioned it that 24 hours later it's going to be working. You can do everything right, and somebody comes along, kicks the wire out of the fans, or the valve sticks open, or something trips. Always check it. And we have remote access on a lot of sites now. I'm sure most customers are the same because they want you to be able to fix it easier. Take the time to have a look because it comes back to bite you in the end if you don't. And it's your reputation. You know, your name's going against that job. You fill in the paperwork. They're going to say, oh, Kev did that. He left it not working. Even if you left it working and it failed 23 hours, 59 minutes later or a week later, it's still Kev who did it. And it's Kev's fault that it's not working. So
I love that you said that because this is it. Like, I keep telling more and more technicians that come into my training program, I'm like, this is your brand. You might be working for a company and you have a logo on your shirt, but it's you.
Yeah.
You know what I mean? It's not the company. It's you. It's your reputation.
Only as good as your last job. And you know, you might have some credit with that customer because you've done them a turn over 10 years. But you put an of the cases in and they break down 12 hours after you've installed them. That's going to eat your credit with that customer and your colleagues very, very quickly, especially if it's something that you had a suspicion about before you left and you were like, yeah, I'll be all right. Because 90% of the time, your suspicion was probably right. And it needs checking. If you come back to it after 12 hours. Of the time. Yeah, you know it. And if you come back 24 hours later and you check it and you go, do you know what? I was right about that. I need to look at it. Then you've done the right thing. If you just assume that it was working when you left and it breaks down, your name is going to be mud. And you don't want that. If you've got to the point where you're commissioning fixtures, you've got some pride in your work. And, you know, take the time to make sure it's right because it's your brand at the end of the day. And unfortunately, as in most, I'm sure it's the same in wherever people are watching from, the refrigeration industry is not massive and your reputation will always precede you. So look after it.
Yeah, and that's it. And that's all it is doing a little bit. It's not even, you know, just doing a verification check. And
yeah.
And if you think, man, I forgot to shut that ball valve or I forgot to open it, go check it. Because I've done it. I've been 2 or 3 hours away. And then I'm like, oh man, I got to turn around.
That's totally true. Totally true. What'll it's and like I say, you can do 50 things right and one thing wrong, and people remember the thing you did wrong, unfortunately, because that's how people are, isn't it? So, you know, have the pride in your work to make sure you've gone back and checked.
Kevin, I love this. We could have talked for another 3 hours just on this topic here, dude. There was so much notes. Like I scribbled down tons and tons of notes again. I really appreciate you taking the time. And I really like the last thing that you talked about your brand and your reputation. That is huge in our industry. It'll take you a long places, and just have some pride in your work. It's so important. And when you're working on controllers, I know there's so many of them out there. We're just talking about one. We talked about Danfoss before. We talked about Corel and Dixel. We talk about a lot of them here. The big thing is that you can learn them. Just continue to watch this and invest in your time. So
your procedure of doing it is the same. The parameter names will be different, and the way you set things up will be different, but the basic way of doing it is the same. Yeah. So it applies across the board.
And then if you're listening to this, go back and rewatch even the first 7 or 8 minutes where Kevin went through his step-by-step procedure on what to do. That's the approach you take on all controllers, on all startup cases, because it is the wiring, it is the transistors, where their location, testing them. And I know I talk to lots of you out there like, Trevor, I got 200 cases, or I got 100 cases, or I got even 30 cases. And they're like, the store needs to be open tomorrow. Well, once again, you got to do it right. Do it right the first time. Don't do it 5 or 6 times. Just do it right the first time. It's going to suck sometimes. Your boss is going to be on you. The customer's going to be on you. Sometimes your hands are tied. Do it right the first time. Take the verbal whipping or whatever it comes from whoever. Just do it right, because once again, it comes back to your reputation. Say, hey, it took me longer, but I did it right the first time, not the 10th time.
And I know multiple people have said it to you on these talks. We don't let gas into any fixture until we are as sure as we can be that we've set it up right. Because once you open it up to the system, your problems multiply very quickly if it's not right. So take the time. If something doesn't look right, address it before you let gas into it, because that is when panic sets in and you're chasing around and you're hurting things that were already running before you got there. Do it the right way, as Trevor said.
And that's the thing too. Like the easy one on construction is you get a case and all of a sudden there's no pressure in it. You mark it. You just put a big mark on it and you say, okay, we'll check and pressure test that one later. Let's use different cases, pulling them off the truck and then you chest test, and then it's going to save you so much time. So that guy that's going to go pipe it, let's pressure test it first. Find that leak before I even pipe it into the system. And that's just one example of many.
Absolutely.
Kevin, this is awesome. We're going to do many more of these. There's lots of great conversation. You're so knowledgeable on controls, and I really appreciate you taking the time. Any final thoughts for the technicians out there?
I think, know what's right when you're doing jobs. Have the confidence. The last message is the right one that you just said. Have the confidence if something's not right to say it's not right and not let it happen. Take charge of your own destiny in that regards. If you get pushed along into doing something, especially when you're commissioning things, bad things tend to happen. You know what's right. Engineers have a feeling for what's right, and stand up for it, because it will pay dividends for you in the end.
Yeah, I love that. So if you enjoyed this, like this, share this with other people. This is how more people find out about it, because there's tons and tons of people that need to hear some of this or see some of this to really get that fire lit under them. Kevin, I want to thank you so much for coming on the Refrigeration Mentor podcast, and we'll do it again.
Take care, everyone. Thanks very much.
Thanks so much, bro.
Thanks, Kevin. Thanks, Trevor.
Cheers.